Okay, we're going to look at some more integration today. We're looking at the integration of e to the x. Absolutely really straightforward because as we saw from differentiation, the differentiation of e to the x was e to the x. So the integral of e to the x is e to the x. Simple as that. Obviously, we're not going to see questions as easy as that in A-level mathematics, but it will involve e to a power of x. And as we saw when we did chain rule differentiation, differential of e to the kx was k times e to the kx. And when we're integrating, we've got to undo that. And so the integral of e to the kx is 1 over k e to the kx, and obviously plus your constant. So let's have a look at how this is applied and how we're going to see it. So your basic case here, integral of 8 e to the 2x, well, I've still got the 8, and then it's e to the 2x divided by 2. Plus c, and rewrite it as 4e to the 2x plus my constant. Nice and straightforward. When I've got an expression like this, 12 divided by e to the 6x, just like I would say when you were in year 12, I would rewrite it first. So I'd write it as e to the minus 6x. We've got that negative power there, and then you apply this rule, and then tidy it all up. So you've got 12 e to the minus 6x over minus 6, but we've got limits to stick in as well, 1 and 0. So we tidy that up. We've got minus 2 is my constant, e to the minus 6x, e to the minus 6, and then plus 2, e to the 0, which is 1. So I'd rewrite that as 2 minus 2 over e to the 6. And that's that one there. Third example, let's have a look at number 3. Similar to before, I've got an expression here, functions of e to the x on the top, functions of e to the x on the bottom, but it's quite straightforward because on the bottom I've only got one term. And just like I would do if it was a polynomial in x divided by x to a power in year 12, I would just divide by that and get everything as year 12 something times x to a power, then integrate term by term. Here I'm going to get everything as e to a power of x, or something times e to a power of x, and then apply this to get our answer. So let's have a look what happens term by term. E to the x divided by e to the 2x, I've got 1 minus 2, becomes e to the minus x, and then minus 10 over e to the 2x, so I write e to the minus 2x. I've now got it as something times e to a power of x, and I can now integrate it. The powers never change, remember, over minus 1, minus 10, e to the minus 2x over minus 2, and plus my constant. Notice I can divide by minus 1. I'm fairly good at this subject, you know. I can divide by minus 1, and more often than not I can divide by minus 2, but you'll be amazed how many people doing A-level mathematics will make minus sign mistakes, trying to be too clever and doing too much in their heads at this stage here. Show that you're applying this rule here. Show that you're applying that the power doesn't change. I'm just going to divide by the differential of the power in this form here. So I'd write it as minus e to the minus x, or minus 1 over e to the x, and then plus 5 e to the minus 2x plus my constant. And that's the answer there. Let's have a look at one that's got a little bit of substitution in. I could do this by inspection because I'm integrating 6x e to the x squared plus 1, and I can tell that what's outside, what's multiplying the function of e, is something to do with the differential there. But it says do it by substitution, so we're going to do it by substitution. Do what we've done before, differentiate it, du equals 2x dx. And I've sort of got it there, but I'm going to split up my integral to be 3 times e to the x squared plus 1 times by that 2x dx, so I can do my substitution there. So it's the integral of 3 e to the u times du, and straightforward, it's 3 e to the u plus c. And then substitute back in to get 3 e to the x squared plus 1 plus my constant. And that's all there is to it.